Hello, this is Kevin, and you're watching Google Engineer Explains. Today we're going to go over LeetCode number 56, merge intervals. All right, what is this problem about? You have a set of intervals here, which is a set of different pairs of numbers, and you want to merge all the ones that overlap. So, for example, 1 to 3 overlaps with 2 to 6. You can see in this in the explanation. And 8 to 10 does not overlap with anything. 15 to 18 does not overlap with anything. So let's just draw this out first to get an idea. Let's do a quick overview of what the problem is asking here. So 1 to 3, we can imagine it like an interval from 1 to 3, like that. It's like it spans from 1 to 3. This next one spans 2 to 6. This next one spans 8 to 10, right? And if you were to merge them, let's just say you just stacked all of them together, all the lines that, anywhere where there's a line, we stack it all together. And what do we get? We get something that goes from 1 to 6, and then 8 to 10. And there's more actually, but it doesn't overlap, so it's not that interesting. So that's kind of how they got this, 1 to 6, 8 to 10, and that's how they did this overlap. There's one other example here, and that's just saying 1 to 4 and 4 to 5 overlap. Yes, so let's say you had an interval, I'll do another one. 1 to 4, and another one 4 to 5. It's just saying the edge case, like if they both start or end on 4, does that count as an overlap? And yes, it does. That's the same as 1 to 5. All right, so I think the problem overview is pretty straightforward. I don't think there shouldn't be too much confusion there. So how do we solve something like this? So I guess the first thing you might think of is brute force. Right now this actually happens to be ordered in terms of the first element is going in ascending order. But we may not actually always have it's not guaranteed that the intervals are in any sort of order. So what you would have to do actually is check each element. Here, let's move this down actually. You'd have to check each element against every other element to find all the ways that it could be merged. That's ultimately going to be an n squared time complexity operation. And I'll explain why. This one has to check against everything else, and then you can merge them all together, and then you can take the next resulting array and then check this one against everything else, right? Take this one against everything else. Each time you may decrease the number of total elements, or you may not. So let's say you don't, in the worst case, then you do, for this element, you check n minus 1, for this element you check n minus 2, for this element you check n minus 3, on and on. That comes out to basically be n squared. It's pretty close to n squared over 2, but in terms of time complexity, we're dropping the constant, so this ends up being time complexity of big O of n squared. I just explained how you would do this. I don't think you need to know how to do this, actually. It's more complicated than the optimal solution, and it's not a better solution, so I don't think it's really worth spending a lot of energy trying to figure out how to do this implementation. It's not too hard. It might be a fun exercise, but you're probably not really going to need to know it for an actual interview. I think in an interview it would suffice to say, oh, the brute force is n squared time complexity. It's not very good. Let's see if we can find something better. So why don't we try to find something better? All right, 3, optimal solution. So I kind of hinted at this earlier. We don't have any information about the ordering of this array. But if we did have some information about the ordering, how might that help us? So let's say we had this as a sorted array. Sorted, let's say. How would that make anything different? Well, the main thing that we have to observe here is that now from this interval, merging it with the next interval, or maybe two upcoming intervals, like let's say this was 3, 3, 4. All the ones that it needs to merge with actually appear right next to it. So basically what you could do is you would take this one, merge with the next one, merge with the next one, see that the next one does not merge, so pop this out. Now we know it's from 1 to 6. And then from here we can just continue on. And we just have to visit each element one time in this solution. So it ends up being an n time operation to do that. And then also we have to do the sort, which is an nlogn operation. We can talk a little bit more about the time complexity at the end, but this ends up being limited by the sort time, which is nlogn, so that's why it's better than the brute force solution. I think this one is actually easier to illustrate via coding, so why don't I just go ahead and do the implementation. But it's pretty similar to what I described, taking each element, merging it with as many as possible, going successive elements, and then kind of sticking that merged interval into maybe like a resulting array and outputting that. So why don't we do that? And at the end we can talk about time complexity, so I'll leave some space there for that. Cool. So how do we do this? So Python has intervals that's a sort. It's in something that works off arrays, or sorry, Python, I guess it's lists in Python. And basically what this sort does is it sorts intervals in place. So that's perfect. By default, actually, this will just sort by the first element, and that's actually exactly what we want. So, but actually, let's talk about sorting defaults and also sorting without mutating. We can talk about some little nuances with sorting at the end, but mostly what we care about is intervals. We get this intervals list sorted. So for this, why don't we just start with intervals.sort, and that does what we want by default. So that's great. What that'll do is sort by the first element, so we get and it does it in place. So we have now intervals that's sorted. All right. Next, what we want to do is we're going to iterate through each element. So why don't we take current one, take that as the first one, and we're going to go ahead, because we're looking at the first element, this could actually return an error if intervals happens to be empty. So why don't we just say, if not intervals, return an empty array. What is this saying? If this is like an empty array, we return blank. And why we can do this with not intervals, because if intervals was an empty array, it actually happens to be falsy. So it's like it'll evaluate to false. So we can just use this operation and return this. So now after this point, we're already returning. So anything after this, we're guaranteed for intervals to have at least one or more elements. So this will not give us any sort of problem referencing the first element because we know it exists. And let's initialize an array that's going to be our result array. All right. So now let's say for pair and intervals. And so we're going to iterate through each interval, and we're going to look at each pair. And we're going to take each pair and compare it to the current one. And we want to see if we can merge it with it. How will we know that? So in this example, 1 to 3, we can just say, like, look at this 2. If this 2 is less than or equal to this one, then we know it could be merged, because we know that this element is going to be smaller or equal, at least, to this one. So if the other side is equal or bigger, then this element will be inside of this interval. So let me write that out, and you can take a second to convince yourself if you need to. But basically, it's going to be something like this. If pair of 0, right, if the first element here is less than, the first element here is less than or equal to the second element of this, which is current at 1, then we're going to merge it in. And we're going to take this current element and combine it with the pair element that we're looking at. So it'll be cur at 1. How does this work? It's going to be the max. So when you merge these together, we're basically going to take the larger of these two elements. So it could be something like, one example that could happen would be like 1, 5 and 2, 2, for example, or 2, 3, let's just say. So in this case, what we actually want is 1, 5. It actually is a wider range and encompasses this. So we don't necessarily, when what we want now, we're basically saying like, okay, this value is smaller than this, so it should go inside the interval. But what should be the output of, what is the max output, max of the second part? And that's just going to be the larger of this one or this one. So why don't we just say cur 1 or pair at 1. So we're just referencing that second element there. Okay, so that's pretty straightforward. And if we don't actually, like let's say we don't find anything, that means there's no overlap here. Like if this pair 0, which would be, this element is actually bigger than this, so that would be, I guess, this case, right? 8 was greater than 4, it does not merge in. So now cur is our entire merged one from all the ones before, and we can basically just say result.append cur, we're adding that in, and now cur becomes, our current one becomes pair. Cool, so that'll basically iterate through and do all the merging for you in this step. Whenever it doesn't merge, whenever we cannot merge anymore, we pop it into we put this cur element into the result list, and then we have a new cur. At the end, we'll basically iterate through every element except for the very last element, which is going to be either merged into the cur or we'll just have it become the cur, but it's not going to be added to the result, so we just need to go ahead and do that. So we'll just add that in once more and return the result. That's basically it. So why don't we just go ahead and submit that. Bam. All right, cool, it worked. A short note in terms of time complexity. So right now we have this part right here, which is nlogn time. This is constant, these are constant. Right here we do one iteration, which is big O of n time. So time complexity is going to be plus big O of n, and that ends up being dominated by this larger term, big O of n log n. So that's what our time complexity is. Actually, why don't you just call this time and space. So this is for time. So what about for space complexity? We're actually doing intervals dot sort, which sorts interval in place. We don't use any additional space. So this actually becomes gonna be constant space actually. Some things that, to make this problem interesting, you could talk to the interviewer about. You could also say, well, what about here with intervals? What if we wanted to have let's say we cannot mutate. So sorting without mutating, what that would mean is basically like you can, instead of having intervals that sort, which is sorting it in place, you could say intervals equals sorted intervals. So you're basically just reassigning it to the same variable here. But basically, this other Python thing sorted takes this original list, but it doesn't mutate it, so it doesn't change it, and it outputs a new variable intervals, which has everything. So I'll just go ahead and show that. So you can see it's exactly the same, nothing has changed. This one would actually be a space complexity of O of n, because you just kind of have an extra list. So that's kind of the mutating thing. It's just interesting. You can, in a real life situation, you might not be able to change the original starting data. So that's something you could talk about. And then another thing you could talk about is the defaults. By default, it actually does sort correctly here, but let's do it in here. Another way you could do this is key equals, check the syntax for this, lambda x of 0. What this is saying is basically for each element, take the first element, x of 0, and this lambda is just an anonymous function. Take the first element and sort by that. For this, by default, it already does that, but this basically just allows you to specify which element to sort on. So let's say we were to say x of 1, that would just mean like we're sorting on the second element. So it would go in order based on what this value is, this value here. So that's all that is. But yeah, it's just it might be worth calling out. Just you can demonstrate that you understand how sorting works in more detail. It's probably not really necessary for this level of complexity of problem, but just something worth knowing, I suppose. And yeah, that's basically it for this problem. So yeah, that's it. Good luck on those interviews.